Semiconductor, most neglected part of class 12th for students. So I am giving you almost all very expected and most important questions answers. Conduction band's definition: empty or partially filled energy band just above the valence band, which is occupied by conduction electrons, is called conduction band. Completely filled energy band, which is occupied by bound valence electrons, is called valence band. And energy band which cannot be occupied by any electron is called forbidden energy gap. So if your preparation is quite well, just go through the questions and see if you can answer them perfectly. If not, then try to learn these answers which are most expected. Then difference between conductor, semiconductor and insulator on the basis of band theory. Conductor. First learn the diagram. You have to draw one rectangle to represent conduction band and other rectangle to represent valence band, and you have to show that the two rectangles are overlapping. Then material in which conduction band overlaps valence band and valence electrons can easily jump into conduction band are called conductor. On y-axis you have to show the energy level. Then semiconductor. At 0 Kelvin, conduction band is completely empty, valence band is completely filled, and it is separated by small energy gap which is less than 3 electron volt. Such materials are called semiconductor. You can pause video and you can check the definition and the diagram. Here also conduction band and valence band, you have to draw two rectangles to show these bands and a small gap between them which will be energy gap, and it is less than 3 electron volt. This is semiconductor's band diagram. Then insulator. Completely empty conduction band and completely filled valence band which is separated by a large energy gap greater than 3 electron volt. These materials are called insulators. So these three differences of conductor, semiconductor and insulators are frequently asked. You don't have to write that those materials which conduct electricity are called conductor. No. On basis of band theory, you have to write these definitions. Now question is asked, what happens when temperature is increased of a conductor and of a semiconductor? For semiconductor, at absolute zero, all electrons are engaged in their bands. No free charge carriers are present, so no conduction of electricity is possible. So at 0 Kelvin, actually it behaves like a perfect insulator. But at finite temperature, some electron gain thermal energy and leave their bonds and are available for conduction. So at finite temperature, its conductivity lies between insulator and conductor. That is why it is known as semiconductor. Now question is being asked, what is hole? So here is the definition. Vacancy of electron left behind in the bond due to exit of bond electron is called hole, and it behaves as a positive charge. Next point to be remembered is that in semiconductor, conduction process of semiconductor is possible due to two types of charge carriers. One negatively charged electron and other is vacancy of electron which behaves as positive charge, which is known as holes. Then when temperature of semiconductor is increased, more and more electrons leave their covalent bond and become available for conduction. So holes are also created when electrons leave their bond. So holes and electrons both number increases. So conductivity of semiconductor increases when temperature of semiconductor is increased. On the contrary, if temperature of metal is increased, number of collisions between electron and lattice atoms increase. So resistance of the metal or the conductor increases. And temperature, if temperature is T, then R resistance at T temperature is resistance of metal at 0 degrees Celsius 1 plus alpha T, where R is resistivity at temperature T, resistance at temperature T. So this is difference between the behavior of metal and behavior of semiconductor when temperature is increased. Metal's resistance increases while semiconductor's conductivity increases, that is resistance decreases. In semiconductor, solid 6 marks question will be asked, and most probably numericals are not given from this section. Very few numericals are being given throughout the last 15 years, 20 years. So these 6 marks are easily available if you can remember these definitions. So definition of intrinsic and extrinsic semiconductor. A pure semiconductor is called intrinsic semiconductor. In pure semiconductor, number of electrons and number of holes are equal. Conductivity of pure semiconductor is very less, and practically it is not useful. To increase conductivity of pure semiconductor, some impurities are mixed. These elements are from trivalent or pentavalent elements. So, controlled mixing of trivalent or pentavalent impurity atoms to increase conductivity of pure semiconductor is called doping. Very important definition. Semiconductor with trivalent or pentavalent impurity atoms is called extrinsic semiconductor. Very important definition. Then extrinsic semiconductor are two types, N-type या negative type semiconductor and P-type or positive type semiconductor. Definition of these two is also very important. When pentavalent impurity atoms are added to silicon pure crystal, the number of electrons increase in comparison to hole in the semiconductor. So, that semiconductor in which conduction process mainly occurs due to electron is called negative type or N-type semiconductor. Since in N-type semiconductor, the conduction process mainly occurs due to electrons, so electrons are known as majority charge carriers. So we got definition of majority charge carriers also and definition of N-type semiconductor also. So contribution of negative charge electron is much more than contribution of holes in conduction process, and such type of extrinsic semiconductor is called negative type or N-type semiconductor. And since in N-type semiconductor holes are much less than number of electrons, therefore electrons are called majority charge carriers while holes are called minority charge carriers. Since pentavalent atoms like phosphorus, when they are mixed in intrinsic pure semiconductor, they donate an electron to this crystal. So pentavalent impurity is called donor impurity. And one thing just to keep in mind, that doping is in our control. So actually conductivity in semiconductor is in our control, and that is why semiconductors are very important in electronics. If a trivalent impurity atom like boron is mixed or doped in pure semiconductor, then it provides a hole. And therefore, when trivalent impurity atoms are mixed with the semiconductor, pure semiconductor, number of holes are much more than number of electrons. As a result, the conduction process in these semiconductors, extrinsic semiconductor, is being done by positively charged holes. And therefore, this type of semiconductor is called P-type semiconductor. Since in P-type semiconductor, trivalent impurity atom provides a hole, that is vacancy of electron. So it accepts electron to its hole from the pure semiconductor's electrons. Therefore, trivalent impurity atoms are known as acceptor atoms. And since major conduction process is being done in P-type semiconductor by the holes which behave as a positive charge carrier, so it is called as positive type P-type semiconductor. You can write in short that when trivalent impurity atoms are mixed in pure semiconductor, density of hole is much more than density of electron. Such semiconductor, extrinsic semiconductor, are called P-type semiconductor. When pentavalent impurity atom is doped in pure semiconductor, density of electron is much more than density of holes, and such type of extrinsic semiconductor are called N-type semiconductor. When the main conduction process is done by the holes, as in P-type semiconductor, the holes are called majority charge carriers and electrons are called minority charge carriers. That is in P-type semiconductor. When main conduction process is done by the electrons, as in N-type semiconductor, then electrons are called majority charge carriers and holes are called minority charge carriers. You can pause video and go through the definitions if you are still confused about the definitions. Now come to p-n junction. When a piece of pure semiconductor, one side is doped with pentavalent impurity and one side with trivalent impurity, then the region where P-type and N-type semiconductors meet is called p-n junction. At this junction, two main important quantities are to be discussed. One is potential barrier and other is depletion region. So let us know the definition of these two quantities. Actually, there are two regions, one where electrons are more and other where holes are more. So electrons starts moving from higher concentration region to lower concentration region. When electrons reach to the lower concentration region, there they meet the holes, and holes are lower energy seats like. So electrons recombine with the holes and want to get settled. So those atoms which get these extra electrons becomes negatively charged, and those atoms which lose their electrons become positively charged. So earlier the N-type and P-type semiconductors were electrically neutral. Remember it. The N-type and P-type semiconductors are having equal number of negative and positive charges, and they are electrically neutral. Thus diffusion of electron from higher concentration zone, that is from N-type site to P-site type, actually creates layer of negative and positively charged atoms at the junction. Now these atoms do not have free electrons or free holes which can move. So the region near junction, which is depleted of all the movable charge carriers, mobile charge carriers, this region is called depletion region. So definition of depletion region. Near junction, the region which is depleted of mobile charge carrier is called depletion region. And due to these negative and positive charge layers, you can see that there is low potential and high potential developed. So at the two sides of the junction, a potential difference is developed, which actually opposes the further diffusion of electron, which is creating this region. So now definition of potential barrier. Potential difference developed across depletion region, which stops diffusion of majority charge carriers across the junction, is known as potential barrier. Very, very important definition. You must write it twice and thrice so that you can write answer properly if this question is in the paper. Now when PN junction is given to electrodes, this system becomes a diode, and diode works as a switch. So what is the diode? What is its symbol? Two terminal device PN junction is called PN junction diode. It is represented with the symbol and arrow, and then this line, vertical line, connected with the two terminal. The arrow represents P side and line represents N side. Now how this electronic device is connected in the circuit, that method is called biasing of PN junction diode. Carefully listen to me. When P side is connected to positive terminal of the battery and N side is connected to negative terminal of the battery, depletion region and potential barrier decreases, and this biasing is called forward biasing. While if P side is connected to negative terminal of the battery and N side is connected to positive terminal of the battery, the depletion region and potential barrier increases. In this situation, diode do not conduct and acts as the broken circuit. This circuit arrangement is called reverse biasing. So in forward biasing, diode allows the current to flow, and in reverse biasing, diode does not allow current to flow. This is VI characteristic of junction diode. This part is forward biased characteristic, and this part represents reverse biasing characteristic. The x-axis V, potential difference applied, is plotted. On y-axis, current is plotted in milliampere. Now you can see that initially when low potential difference battery is applied, there is very small current flowing because of potential barrier. But when potential applied and potential barrier becomes equal, after that, the potential barrier is overcome by the potential difference applied and current starts flowing drastically. This is forward biased VI characteristic, and we say that PN junction offers almost negligible resistance when forward biased. While when the reverse biasing is applied, there is no current practically flowing through the diode, but minority charge carriers present on P side, which are the electrons, and minority charge carriers on N side, which are holes. For them, the potential barrier and the electric field due to potential barrier is a favorable condition, and they cross the junction and constitute a very weak current, which is called reverse saturation current. So if the reverse biased potential difference is applied, initially for the low applied reverse biased, there is no current. This is very small microampere level current, which is called reverse saturation current. But if negative potential difference or the negative biasing or the reverse biasing is increased and becomes more and more further negative, there is a situation when the junction breaks down and current drastically increases. So this potential at which junction breakdown in reverse biasing is called breakdown voltage. PN junction offers very high resistance in reverse biasing. The last segment is of rectifier. Diode is used as rectifier. So what is rectifier? It is a device which blocks one half cycle of alternating current, and only one cycle of alternating current is allowed to pass through, and that way AC is converted into DC. So what is rectifier? Which converts AC into DC. Now there are half wave rectifier and full wave rectifier, and I expect full wave rectifier this time, but I will give you both the circuit diagrams and input and output diagrams. So mostly they ask you to draw the circuit diagram of half wave rectifier, input current and output currents waveform, full wave rectifier's circuit diagram, and input and output currents or voltage waveform. See how you are supposed to draw half wave rectifier. This is the representation of a transformer which will convert 220 volt into the desired voltage low potential. So this is step down transformer. These two lines represent lamination. Only one diode is connected with the one end of the secondary. Now see the circuit diagram. This end is connected with the earth 0 volt. So whatever input AC is applied, the V voltage appears on this end. Here the diode is connected with a resistance to this end of the secondary, and this end of the secondary is earthed, that is 0 volt. Now the output is taken across this load resistance RL. So output will appear across this resistance. In positive half cycle, the P side will be positive and the N side will be negative. So it will be forward biased, and you will have current flowing in secondary and through secondary in this load resistance. The diode will act as the simple conducting wire and will allow the current to flow through this. So whatever variation is taking place in input, the same variation will appear here across the load resistance, and you will get the positive half cycle of input in the output. But during the negative half cycle, this end is 0 volt, but this end becomes negative. This end becomes negative. So now P side is negative, N side is at 0 volt. So now P side is at a lower potential than N side, and it is reverse biased. Now it will offer high resistance in the path of current and will not allow current to flow like a switch. It is open. So no current will flow through the diode. So no current will flow through the load, and this half cycle will disappear in the output. So this is input, this is output. So all the positive half cycles will appear in the output, and all the negative half cycles are rectified. So the current which is alternately changing its direction, here current is not changing its direction, it is just changing its magnitude, but it is in the same direction. So AC is converted into DC with half positive cycles. But as I said, I expect full wave rectifier in question paper if it is there. So the same transformer, primary, this is secondary. Now observe carefully. The center of the secondary is connected with the earth. It is called center tapped transformer. Now there are two diodes. Just observe, from the secondary, one diode is connected to the center tapping of the secondary and through the load resistance. The other end of the secondary, through this diode D2, is connected to the center tapping through this same load resistance. Now when input current or voltage is applied across this primary, what happens? When positive half cycle is there, positive, this end is at 0 volt, and this end is positive, this end is 0 volt, this end is negative, this end is 0 volt. This is the actual working. If you want to know the details, then you can go through the complete explanation. But if you don't have time now, then just go through this point, that in central tapped transformer, this end is positive, then this end will be positive, this end will be negative, this end, this will be 0 volt. So the P side of the D1 is positive, the N side is at 0 volt, this is forward biased, and it will allow the current to flow clockwise. In negative half cycle, this end is negative, this end is negative, this is 0 volt, this end is positive with respect to this end. So this time, here the P side is connected with the negative and N side is connected with the 0 volt. It is reverse biased, no current in this segment. But this side is connected with the positive and this side is connected with the 0. So this D2 is forward biased and current will flow through D2 again anti-clockwise, but just observe the direction of current through load resistance. In load resistance, current is flowing this side due to D2 also and this side due to D1 also. So actually using two diodes, both the half cycles appear in the output. But since the current is not changing its direction in load resistance, it is fluctuating, its magnitude is changing, but its direction is not changing, and both the energy cycles appear in the output. So learn to draw the input diagram and output diagram. In the first part, for positive half cycle, this end is positive, this end is negative, this end is positive, this is 0, this is negative, this is forward biased, this is reverse biased, current flows through this direction. In negative half cycle, this is positive, this is negative, in negative half cycle, this is negative, this is positive, this is negative, this is positive, this is 0. So this time D2 is forward biased and D1 is reverse biased. So D2 will conduct but in the same direction through Rn. So output will come with fluctuating DC. Learn to draw this diagram, draw it twice or thrice. So this is quick revision of at least most important and expected questions I have discussed in these 15-16 minutes.